Guys, Coach RJ here and welcome to our new episode of RJ's Math and Science Workshop where we learn as one and we learn with fun. Okay, so I know that you are excited for our new lessons and this continues our fundamental rules of integration, part of our integral calculus class. So stay tuned and have a great day. So now our lesson for today is all about integration or integrals of hyperbolic functions and integrals yielding inverse hyperbolic functions. So this is a continuation of fundamental rules of integration, but this time we will go to our last part of transcendental functions, which is the hyperbolic and the inverse hyperbolic functions. So this is not familiar to you because this is usually taken in the college na or some sorts of analytical geometry. If some students will recall, this is higher part of transcendental functions, but it is really easy lang. So we will divide this our session into two. We will talk about hyperbolic functions and we will also talk about inverse hyperbolic functions. So before we discuss, do not forget to subscribe to my YouTube channel, watch my videos, past videos, and keep learning and have fun, okay? So let's start. So these are the rules for hyperbolic functions, guys. So mapapansin niyo, meron siyang resemblance sa trigonometric functions because sin h, meaning hyperbolic sine. It is introduced in unit hyperbola. So kasi kaya nga tayo may h because it talks about unit hyperbola. Okay? So still our assumption here is u is a differentiable function of x. So this is our continuation of our rules. Nag-stop tayo sa 20 for the past video. So we will add 8 for the hyperbolic. So meron tayong dadagdag later for inverse hyperbolic. Okay? So for our hyperbolic function, we have the integration of sine u or the hyperbolic sine u du is equal to hyperbolic cosine of u plus c. And for the next one, the integration of hyperbolic cosine of u is equal to hyperbolic sine of u plus c. And as you can see here, lahat po ng basic trigonometric function, which is the hyperbolic cosine, the hyperbolic sine, and the hyperbolic tangent, wala po silang negative. So that is the pattern that you need to observe also. Okay? Para mas madali yung integration. If you're familiarizing, then okay. If you have memorized these rules, then better. Okay? And as you can see here, all the reciprocal hyperbolic functions, yung cotangent, then secant and cosecant, they have negative sign. And this is their respective integrations. For hyperbolic secant squared, u, we have tangent u. The hyperbolic cosecant squared, we have negative cotangent or hyperbolic cotangent. And for the product of hyperbolic secant u and hyperbolic tangent u, we have negative hyperbolic secant of u. And we have the product of hyperbolic cosecant u and hyperbolic cotangent u that will result to negative hyperbolic cosecant u plus c. So medyo mahirap i-pronounce kasi hyperbolic cosecant. You can use sin, then cos. Depends kung ano notation ninyo. But for formality, we will just use hyperbolic sine and hyperbolic cosine. Okay? Then for this one, we add two rules. Kasi hindi naman na-introduce dito yung integration na yung dati hindi na-introduce yung integration nito ay yung derivative nito. So now we will add na lang para mas madali. So the hyperbolic tangent of u du, we have ln of hyperbolic cosine of u plus c. Then for hyperbolic cotangent of u, we have ln of hyperbolic sine. And do not forget plus c for integrations, okay? So these are the rules for integration of hyperbolic functions. So we will just give you examples for this. Okay? Some 3 examples for this lesson. Number 1, the integration of the hyperbolic sine of 3x minus 1 dx. So, ganito lang kasimple. We let u as the function of the angle. So, this is 3x minus 1. Then, the differential is du is equal to 3 dx. Since there's no 3 dx here, we will divide both sides by 3 so that dx lang yung matira. Sorry, 1/3 pala yan. 1/3 du is equal to dx. Then, plug in all values. So, integration of hyperbolic sine of u times 1/3 du. Labas natin si 1/3 since this is a constant. So, the 1/3 integration of hyperbolic sine u du, then this will result to 1/3 hyperbolic cosine of 3x minus 1 plus c. Okay? So, ganyan lang ka-easy. So, we'll proceed to our second example. So, if you have questions, guys, you can raise it down in the comment section. And don't forget to subscribe to my channel. Then, let's proceed to our second example. The integration of x hyperbolic tangent of x squared dx. So, as you can see and observe, these are the products of two functions. X, then tangent, hyperbolic tangent x squared. And it is a bit complicated, diba? When you see here. But, di problema yan. So, we'll still use u substitution here. Okay? So, for u substitution, let u is equal to x squared. And our differential is 2x dx. Since there's no 2x dx in this term, or in this expression, we'll divide both sides by 1/2. So, sorry, we will divide both sides by 2. So, this becomes 1/2 du is equal to x dx. Now, we can plug in our values. So, our answer now will be integration of tangent or hyperbolic tangent of u 1/2 du. Okay? So, ilalabas natin si 1/2. 1/2, the integration of tangent of u or hyperbolic tangent of u du. So, the value of this one is 1/2 ln of hyperbolic cosine of u plus c. Or, to plug in the value of u, 1/2 ln of hyperbolic cosine of x squared plus c. And this is our final answer. Diba? Ganun lang kadali. So, for the last example of this lesson, okay, let's have this one. The integration of x times hyperbolic cosecant squared 1/1 minus x squared. The integration of x hyperbolic cosecant squared 1/1 minus x squared. So, bali ito yung angle ha. Dx. Angle to siya. Para siyang ganito Para hindi kayo ma-confuse. Ganyan. Ito na term ha. This is equal. So, paano natin siya masosolve? It's still the same. We will still use u substitution here. So, let u is equal to 1 minus x squared. Then, du is equal to negative 2x dx. And there's no negative sign here or negative 2x dx here. So, we will divide both sides by negative 2. So, this becomes negative 1/2 du is equal to x dx. Now, we have now all the values, then we can plug in. So, the integration of hyperbolic cosecant squared u times negative 1/2 du. So, negative 1/2, the integration of hyperbolic cosecant u du. And this becomes negative 1/2 times negative cotangent or negative hyperbolic cotangent of u plus c. And negative times negative is positive, so this becomes 1/2 hyperbolic cotangent of 1 minus x squared plus c. So, di ba? So easy. And that is our example for integrals of hyperbolic functions. Okay? So, we will have a practice quiz for this lesson, and let's tune in for our integrals yielding inverse hyperbolic functions. So guys, here are now our fundamental rules for integrals yielding inverse hyperbolic functions. Usually guys, hindi na ito siya ginagamit. Pero I will just introduce this one to you para for additional knowledge. Okay, kasi meron kasing mga equivalent itong mga values na ito when we reach our lesson in methods of integration, particularly in trigonometric substitution, because with these expressions we can use trigonometric substitutions. Okay, but for the sake of discussing or for the concern of the inverse hyperbolic functions, then we will discuss these 5 additional rules. Still, it has the same assumptions for the inverse trigonometric functions, where u is the differentiable function of x and a is a constant. So our rules are starting with the integration of du all over a squared minus u squared is equal to 1 over a hyperbolic inverse tangent of u over a plus c. Or usually, interchangeable kasi yung hyperbolic din inverse. It's still the same, but it denotes this case. Okay? So for the second one, we have the integration of du all over u squared minus a squared is equal to negative 1 over a inverse hyperbolic cotangent u over a plus c. For the third one, we have the integration of du all over the square root of u squared plus a squared is equal to the hyperbolic inverse sine of u over a plus c. Then for next integral, we have the integral of du all over square root of u squared minus a squared is equal to inverse hyperbolic cosine of u over a plus c. And for our last one, we have the integral of du all over the square root u times the square root of a squared minus u squared is equal to negative 1 over a hyperbolic inverse secant of u over a plus c. You take note of 1 over a, guys, ha. It's because, again, like the previous video, it is necessary for us to know over this one. Kasi maraming namamali dyan, nakakalimutan nila yung 1 over a sa integrations. Do not forget that one, okay? So, let us solve some examples of this lesson. Guys, we will solve 3 examples, then again, another practice quiz, okay? So, for the first example of this lesson, of the current lesson, we have the integration of dx all over the square root of 4x squared plus 1. So, sa unang tingin pa lang, guys, alam natin na sine siya. Pero, mas madali siya kung ating himay-himayin yung steps. Okay, so, again, yung substitution, we have u is equal to 2x. And our du is 2dx. But there's no 2 here, so we will divide na lang both sides by 2. So, 1/2 du is dx. And our a here is 1. So, for this case, we can transform this one into dx is equal to the square root of quantity 2x squared plus quantity 1 squared. Then we plug in our values. So we have 1/2 du all over square root of u squared plus a squared. And for this term, we know that this is a inverse hyperbolic sign. So, lalabas po na natin yung 1/2 du all over the square root of u squared plus a squared. Then, 1/2 inverse hyperbolic sine of u over a. So, 2x lang at ilalagay plus c. So, this is our final answer. So, di ba ang dali? Dali lang siya, guys. Di ba? So, let us have second example. So, guys, don't forget to ask questions if you're confused, guys, ha? Or if meron kayong gusto i-clarify, you can comment there in our comment section, okay? So, for our second example, we have the integration of the square root of 4x squared minus 9. Again, sa palagi natin ginagawa, use substitution. So, let u is equal to 2x. du is equal to 2 dx. Then, since no 2 here, so we will divide both sides by 2. So, 1/2 du is equal to dx. And our 3 here, and our a here is 3. So, sabi ko na. So, our a here is 3. So, we solve dx to the square root of 2x squared times 3 minus quantity 3 squared. Then, we substitute. So, we have 1/2 du all over the square root of u squared minus a squared. Okay? So, for this case, we use 1/2. Sorry, 1/2. Ilalabas natin yung 1/2. Then, for this case, cosine siya. Hyperbolic inverse cosine. Inverse hyperbolic cosine. So, this is hyperbolic cosine of negative 1 u over a. Or what is u? 2x. Then, our a is 3 plus c. Okay? So, ganyan lang siya, guys. U squared over a squared. Okay? And for last example, we have the integration of dx all over x squared plus 6x minus 16. So again, encounter na natin tong case na ito sa inverse trigonometric functions because there is a trinomial. But how is it possible in this lesson? So paano siya? Again, later na yung let you. We will transform first this expression into its vertex form by using completing the square. So dx all over, make this one a perfect square trinomial. So x squared plus 6x plus 9. So when I add 9, I will also subtract 9. So minus 16 minus 9. So that this expression will be, say, 16 minus 9. Then I'll move it in the middle. We can reduce this one into square of binomial. So the integration of dx all over x plus 3 squared minus 25. And our u here is x plus 3, du is dx, and our a here is 5. So, du all over u squared minus a squared. Then, our final answer is, we have now the rule for this case. So, our final answer is negative 1 over a, which is 1/5 inverse hyperbolic cotangent of x plus 3 over 5 plus c. Okay? So, this is our final answer. So, it is important, guys, to know these rules because masasanay kayo sa solving nito and hopefully you will find some methods that will make your solving easier. And as you recall your algebra and as you recall your analytical geometry and differential calculus, it is up to you to solve it more quicker and as fast as you can. Okay? So, here is your practice quiz for the inverse hyperbolic functions and stay tuned. so much guys for watching my videos. Don't forget to subscribe my YouTube channel and click the bell button for more notifications, and keep updated to the integral calculus class, and share this one to your friends that is currently taking their integral calculus sessions and preparing for their summative assessments. Shout out po for Mrs. Giselle Cagape and Mrs. May Ann Nable. These are my mentors in Daniel Araginaldo National High School in Davao City. Hello ma'ams. Thank you so much and God bless you always. And to our viewers there, thank you so much for listening to my videos. Stay safe and God bless you always.